All right, this is 1:30 my time. So, do you hear me? Fred, my microphone is already. Woohoo! Let's get going then. So, all right, yes, three screens. Let me navigate them. Okay, next slide. So, today I will uh, talk about how we try to create chaos in databases, maybe obviously with a goal to find a little more stability in our databases. And I already have some nice conversation in this chat. People who know me, but if you don't, I'm Vadim Tkachenko. I'm CTO and the co-founder at Percona since pretty much 15 years ago, like Peter mentioned in our keynote. And you can find me on Twitter and on my email, which you can guess, I believe. And before we get into chaos, let's talk a little bit about Kubernetes and the databases. And our Kubernetes offerings so far was Percona XDB cluster operator, Percona server for MongoDB operator, and just today or yesterday we announced our PostgreSQL operator. So as you see, we put in our efforts into Kubernetes offerings, and I will explain a little bit in a while why. But my focus today mostly will be about Percona XDB cluster, but in general, all the same principles will apply to other two operators. And to kick the ground a little bit, if you're not familiar with what is Percona XDB cluster, we view Percona XDB cluster as multiple MySQL servers connected through group communication. Do not mix with group replication, Fred. And we have multiple nodes in this picture, three nodes, which communicate each with other, and we can perform theoretically read and writes on each node. And what is our goal with Percona XDB cluster? With our cluster technology, we trying to achieve high availability while preserving data consistency. So data consistency is priority number one for us. We do everything possible to keep your data safe, but at the same time, by providing multiple nodes, we're trying to achieve a high available solution. It's all achieved by virtually synchronous communication between nodes. And all this why we allow transactional workload with all traditional ACID properties. And obviously for database and especially for clustering technology, two components very critical is storage. Storage is critical for performance, because if you store data on storage, in a lot of cases, the performance of your cluster, which will be defined by how fast you can retrieve or store your data. And for clustering technology, another component critical is a network. It is critical, obviously, for connectivity between nodes and for message delivery when cluster nodes exchange messages each with other. And with this, why do we focus on our Kubernetes offering? We believe Kubernetes is a way to run databases in the future. There are multiple prepositions for that. First one, we often want to run data. We currently infrastructure as code is a very wide used term, we see with Kubernetes we can make step forward and achieve a database as code. That is, you can define your infrastructure, including databases in text form, which can be shareable, multi-versioned, and reusable between inside company. Other trend we see that a lot of companies already using literally thousands of database instances, and you need a way to manage them and keep your sanity. And again, that one way of achieve that is to use infrastructure as code. And we believe Kubernetes offers that, while at the same time Kubernetes becomes industry standard to manage all these environments. And portability provided from containers and Kubernetes environment allows you to escape lock-in solution, and it actually allows you achieve, let's say, movability. You're not locked in the single cloud like Amazon Cloud or Google Cloud or Oracle Cloud. Fred, I know you like Oracle Cloud, but in Percona, we don't want anyone to be locked in some single solution. And the Kubernetes, we see Kubernetes as a mechanism to provide a movability between clouds, that you're not locked in. And why do we focus on our operators? In our operators, we offer a way to run databases strictly on the Kubernetes primitives. We provide automatic way to provision and manage configs. We provide upgrades from minor, but also for major version, which can be tricky, but we're trying to automate and make it painless for you. We provide fully automated backups and recovery. With this, we provide great integration with our monitoring and management solution. And we also allow you vertical, horizontal scaling. And yes, we recommend to, if you looking to run your database in Kubernetes, we recommend to use our Kubernetes operators. Yes, Fred, I know you don't like running database in containers, and I will talk a little bit about that, because I was like you, but I changed my heart. So, and back to Percona XtraDB cluster features. In our operator, again, we provide fully automated deployments. We provide high availability solution with no single point of failure. And our cluster, our operator is able to provide even a self-healing mechanism by automatically recovering from failure of single database member. But actually, in recent releases, we went even further. We can provide some kind of self-healing even from multiple failures. And to be able to provide availability, we require odd number of pods, and you can do simple math. In 3 nodes cluster, we can survive 1 pod failure, and 5 nodes cluster, we can survive 2 pods failure, and so on. So you can estimate how many nodes cluster you need to survive several pods failure. And like I mentioned, even if we have a full network outage, that we can recover from that almost automatically with our Percona DB cluster operator. So, Fred, back to your concern. Yeah, question I hear very often. Question I hear constantly: is Kubernetes ready for databases? And I had the same exactly concern a few years ago. Can it handle stateful application? Can it handle a persistent storage? And while we started our Kubernetes operator development, during this year, we saw major improvements in all components that's needed to successfully run databases. Network plugins. There is a variety of network plugins available for Kubernetes, which you can choose and successfully run your network communication. There is a great progress in storage components. I even did not fully caught up with recent development. In the newest Kubernetes versions, there are already snapshot and cloning capabilities available for storage that bring us even closer to provide cloud-like experience where you can do snapshots and clone your database pretty much on fly. Great improvement in operator APIs. So our answer is yes, Kubernetes is ready for databases. Well, does it mean should you use Kubernetes for databases? That might be different answer. And if you looked a little bit into Kubernetes, clouds native, you're probably very familiar with this pets versus cattle analogy. When if you still treat your single and precious database as pet server, where you have dedicated team which manages that server, whereas that single database server handles multiple workloads and multiple application, probably still Kubernetes would not be best case for you, and likely will just add overhead and extra work for your database team. But if you started to look into moving, treating database service as a cattle, where you have multiple database servers, where you have multiple database instances, and I, for myself, define multiple, maybe like 30, 40, there's some entry barrier when you can start looking into Kubernetes, where you want minimize the DBA team, or do you don't have DBA team at all, and you want your developers or QA create and destroy databases on demand and rely a lot of automation infrastructure as code, then our answer is yes. You should look into using Kubernetes for databases. And actually, you might heard from our keynotes, we offer a technical preview for our database service. It is available as part of our PMM, and you can hear more about our database service offering today at 4:30 p.m. Eastern time. Now let's go into chaos testing and why I started to look into that. And you might guess this is connected to Kubernetes. And while I just offered that Kubernetes is great for database deployments, but Kubernetes also multiplies some problems. If you have multiple database instances with unpredictable application workloads, that might be not be great for your database instances. If you have massive scale deployments, there is a network plugin software, there is storage plugin software, and all this software comes with bugs. So how can we ensure that our database as service is still able to handle workload you put into it? And as Kubernetes multiplies all these problems, I believe also Kubernetes makes testing easier. If we can automate the database deployment, why cannot we automate failure? Because in chaos testing, we're looking to introduce as many failures and unpredictable failures in your database environment. So that's also possible with Kubernetes. And currently, I'm aware of two good development in chaos testing frameworks. This is a chaos mesh, which I personally, I'm not saying chaos mesh is better than Litmus. I'm just started to play with it myself a little bit more, and I'm just more familiar with it. Yeah, I think I'm running a little bit out of time, so I will speed up a little. We'll see how it goes. And there I would like to show what kind of testing I applied to my cluster and what kind of experience I received with this. And for this, I use testing setup. Again, this is Kubernetes. If you use it, you should be familiar with kubectl pods. We see we're running 3 database pods and 3 HA proxy instances. For client, I will use sysbench with sysbench TPCC workload. And I wanted to test, initially I wanted to test very, very simple cases, but even in cases being very simple, I think they can provide very inspirational output just for start and keep you going. And what we wanted to do, we would like to do pod disruption. We would like to simulate node crash and, for example, node lost at all, as we claimed, our 3 pod clusters should survive 1 pod failure. So what will happen in this case, and or what will happen in case we do more than the 2 pod failures? How our cluster will handle that? Also, as our cluster depends a lot on network, as I mentioned, what happens if there is network disruption? What is partial link lost between one node to another node? What if what we have whole network disruption? And with chaos testing frameworks, I found it's very easy to do. For example, we want to define periodical pod disruption. We just kill 1 pod every 10 minutes in this case. How our cluster will perform. And we can see from our sysbench TPCC output, we can apply a failure scenario, and we can see how our cluster will perform. And you can see there is some transactional going, but then for 5 seconds, there is no transactions at all. And this is a timeout which cluster takes to figure out that one pod is not available, and basically kicks out that pod out of cluster. So after 5 seconds timeout period, cluster continues going. And in my previous talks, I was received question: is this 5-second downtime? And I don't really see this downtime, because your queries are not killed and your workload not killed, but your queries are stalled for 5 seconds. And that's unfortunately a balance we need to take between figuring out how soon we should consider a pod not available and resume workload, and that's a timeout is configurable. Now let's configure network disruption. In this case, in this scenario which I define, I just kill the network communication in one direction, from pod 1 to pod 0. I was very interested what will happen in this case. And if you look into Sysbench output, we can see actually in this case it took only 3 seconds for cluster to continue to communicate, and it was really interesting what happens in background. If you take a look at logs, we see actually XDB cluster took, let's say, a little bit cheating, and it figured out that one network channel not available, so it started to relay messages through another available node, and basically in 3 seconds it continue message delivery and continue to handle workload. Now, what it happens if network totally not available to one pod, and let's say we want to disable network communication for 20 seconds. Well, in this case, for XDB cluster, it is not different than if pod just not available, and you see it took 5 seconds for cluster to figure out that there is no network communication to broken pod, and it resumed traffic in 5 seconds. Yeah, a question: what if two pods lost connectivity? How cluster would behave in this case? Well, and like I said, if you have 3 pods in total and 2 pods lost connectivity, cluster will become unavailable. But also interesting to see, I think it's important to test also for your application, how your application will handle this failure. And in this case, we see that actually Sysbench is not able to handle error which cluster provides to application. Sysbench exits with error by itself. That in this case, cluster returns error, which indicates that majority lost. It cannot handle queries anymore, but this error which Sysbench could not handle by itself. So in this case, I would like to show importance of this chaos testing, not also to test your database layer, but also another components, how and exactly how your application will behave if there is network problems or if there is a problem with database. Can your application handle this gracefully, or it will fail like with this particular case with Sysbench? And of course, I showed you 2 happy scenarios how cluster is able to recovery, and I could stop on that, saying XDB cluster is great. But actually, I want to show several cases where using this chaos testing, and that's why I think it's important and exciting. When using chaos testing, I found a few issues with XDB cluster by itself. And I'm glad I found them, because it allowed us to improve stability of our XDB cluster and our database as service offering. So one unhappy scenario which I found, and it is a totally open bug which you can go and see communication on that bug. I found if one pod by some reason lost connectivity for longer than 60 seconds, then node was not able to join cluster back. It stuck in this endless loop. It tried to perform IST, incremental state transfer. It was not successful because cluster already moved forward. Node failed to SST. By some reason, it also was unsuccessful. Then pod was killed from Kubernetes, and it started from start, and it was kicked again. And basically, cluster lost that sick pod forever. So good news, we are working, and the fix will be available for this one. So this is where chaos testing was produced good results for us. Another unhappy scenario, I applied frequent disconnects. For example, again, that network failure, which I described previously, I just applied that every 30 seconds we disconnect a pod for 20 seconds. And unfortunately, it resulted in application getting stuck. And from process list, we could see that application was waiting for commit message, but cluster was not able to perform that commit message. Because cluster did not return success on that. And in result, application was stuck. That was a totally hand workload. And it also was a bug in our Percona DB cluster, which as outcome, we found a group of bugs which is similarly connected to each other. And we performed focused effort to fix this class of issues. And as good news, like mentioned, Percona DB cluster 8023 will come with a lot of fixes. It will fix these bugs. There will be new bugs? There, time will tell. When I will apply new chaos testing techniques, maybe I will need to go a little bit more sophisticated to find more failures. So to highlight chaos testing benefits, I found that very important, actually kind of insightful to see what happens with your database layer when you apply failure scenario. And with Kubernetes, it is very easy. You can actually automate it. And I believe you can actually apply it to your CI/CD pipeline. And you can apply not only single failure, you can multiply these failures as layer over layer. And actually, I had fun running this. Maybe not so much my engineering team when I found all these bugs, but I believe, yeah, as outcome, our Percona DB cluster will become more stable and more solid. And again, I believe chaos testing will be beneficial not only to test your database layer, but also application layer, how your application will handle database failures, how your application will handle pods failures. That's all will be possible to find if you use this chaos testing techniques. And that's all my 30 minutes. Thank you very much. I see that a lot of exchange in the chat. I'm not sure I will be able to through all questions, but I'm maybe to answer to question or two if you ask them right now. If not, then I think that's all from me. I will stop sharing. And Katie, you can take it from here. Thank you, guys.